Welcome you all viewers. Now this session I'm going to deal with the subject name Power Electronics and subject code is E8552 and the topic for this video session is SCR working and static characteristics of SCR. Represented by M. Uma Maheshwari, AP AAA Department, the Engineering College. Now today's topic is about the SCR. It is silicon controlled rectifier. So why the name silicon controlled rectifier? It is the material, it is made up of silicon and the controlled because we are able to control the voltage across the device. So output voltage we are able to control, and the name rectifier because we are converting the SCR device is used as an rectifier which converts AC to DC, variable DC, hence the name controlled rectifier. So this is the name explanation of SCR, silicon controlled rectifier. A silicon controlled rectifier, it is a 4-layer device. Okay, and it has got 3 terminals: anode, cathode, and gate terminals. So these terminals are represented by symbols like this: G, gate terminal; anode, A terminal; K for cathode terminal. And the main application is used as a switch, and it is used as an amplifier and a rectifier. These are the main applications of SCR. Now this is the schematic diagram of SCR and symbol of SCR. Here I have already told you it is a 4-layer device. So alternative P-type, N-type, P-type, N-type materials. And it is a 3-junction. It has got 3 junctions. Between this P and N is the junction J1, and this N-type material and this P-type material is the junction J2, and this P-type material and N-type material is the junction J3. So it is a SCR is a 4-layer device and 3 junctions, and has got terminals: anode, cathode, and the gate terminal. The gate terminal will be closer towards the cathode terminal. Okay, so this is about the schematic diagram of SCR. Now the structure of SCR. So this is the basic structure of SCR. So here you can see that it is a 4-layer P-type, N-type, P-type, N-type material. Whereas the doping of the layers are different. So the P-type layer, which is connected to the anode junction, has high doping. The P plus represents here it is heavily doped. So the doping of it is 10 power 19 centimeter per minus 3, and N1 layer, which is N minus, which represents it is lightly doped, and the doping here is 10 power 13 to 5 into 10 power 14 centimeter per minus 3. And the other next P2 layer, it is heavily doped, which represents by the plus here, and the doping level is 10 power 17 centimeter per minus 3. And the doping of N layer, that is N2 layer, it is represented as N plus. N plus represents heavy doping, and the doping it is 10 power 19 centimeter per minus 3. So it is a 4-layer device and has got 3 junctions: J1, J2, J3. The anode terminal is connected to the heavily doped P-type layer, and the cathode connector is connected to the heavily doped N-type layer, and the gate is connected to the inner P-type layer. Okay, and the gate is connected nearer to the cathode terminal, and this N minus layer is called the drift region. So this drift region is responsible for the breakdown voltage of the device. Okay, and the thickness of this drift region determines the depletion region with the thickness. So this N minus layer is called the drift region. And this is your elementary circuit for obtaining the IV characteristics. Here you can see the gate terminal, which is connected to the source voltage. It is represented as ES. And the anode and cathode voltage are connected to the external power supply through this load. Okay, and the voltage across the SCR is represented as VA, and the current through the SCR is represented as IA. Now this gate signal, the gate terminal is open circuited. Okay, and here it is the source connected is ES. So this is the circuit for obtaining the VI characteristics. There are 4 modes of operation in case of thyristor. The first mode of operation is reverse blocking mode, or we say the thyristor is an open circuit. The second mode of operation, it is reverse conduction mode. The thyristor closed circuit. And third mode is forward blocking mode. Thyristor is an open circuit again. And the fourth mode of operation is forward conduction mode. So thyristor is in closed circuit. Let us look into this four modes of operation one by one. So first mode is reversed blocking mode. So in case of reverse blocking mode, the polarity, how the polarity is connected, the external voltage source is connected. So here you can see that the anode is connected to the negative terminal of the external supply and the cathode is connected to the positive terminal of the external supply, and we are able to see that the gate terminal is open circuited. There is no voltage potential given to the gate terminal. So this is the polarity with respect to the three terminals. Now we are going to see what about the polarity of the junctions, whether it is forward biased or reverse biased. Now with respect to this junction J1, here you are able to understand this. The minus connected to the p-type layer and the plus of this cathode is connected to this n-type layer. So we say that this junction J1 is, here you can see that it is reversed biased. So p-type connected to negative, n-type connected to positive, this junction is reverse biased. Similarly, when with respect to junction J2, so here you can see that this minus is connected to the n-type layer and positive is connected to the junction p-type layer. So this junction J2 is forward biased. And for junction J3, this minus of this anode is appearing across this p-type layer and positive of this cathode is appearing across this n-type layer. So this junction J3 is reverse biased. So whenever this junction J1, J3 are reverse biased, there exists a depletion region across this junction. So because of this presence of depletion region, there is no current flow through this SCR. So the SCR is said to be in off state or open circuit state. This is happening in case of reverse blocking mode. And what is reverse conduction mode? So in case of reverse conduction mode, here we are not giving any polar gate terminal here, whereas the anode to cathode terminal, the reverse voltage is increased. So when it is increased to a particular value which is greater than the reverse breakdown voltage, what is happening? This reverse bias junction J1, J3 breaks down. So once this reverse bias junction breaks down, the current flows through this um, SCR, that is known as the reverse current. So this reverse current will be a large value of current and this large reverse current should be avoided. So the working of the SCR behind this breakdown voltage should be avoided. Now with respect to forward blocking mode. So what is forward blocking mode and what is the potential across the anode and cathode terminal? So in forward blocking mode, the anode is given as positive and cathode is given as negative, and here the gate circuit is open terminal. So here, as I already explained you in a similar way, we can also refer here the junction pole, whether it is forward biased or reverse biased. So the junction J1 and J3 are forward biased, whereas the junction J2 is reverse biased. So with respect to the reverse biased condition, there exists a depletion region here. And in this forward blocking mode, whenever the anode and cathode is polarity is this, there is no flow of current. Only a small leakage current will be flowing. That is due to the temperature effects because of this depletion region across the junction J2. Now, what is forward conduction mode? So, in forward conduction mode, with respect to the anode positive and cathode negative, here you can see that the gate terminal is short circuited and the gate potential is applied. The voltage across the gate and the cathode is given. So we name this as the gate voltage Vg. So G is connected to positive and K is connected to negative. So gate voltage is positive voltage is applied. So with respect to this gate terminal, what is happening here is there is flow of charge carriers into this layer. So there is flow of charge carriers. Because of this flow of charge carriers, the electrons try to travel across this junction J2. So when the electrons travel this depletion region, the number of immobile ion reduces. And at one particular value of gate voltage, the depletion region vanishes and the SCR starts conducting. And the flow of current through the SCR is from anode, p-type layer, n-type layer, p-type layer, n-type layer and to the cathode. In this way, the SCR starts conducting. So this is about the working of SCR with respect to this forward biasing and reverse biasing of an SCR. Thank you all.